So how do we build a heap? Well, because it's complete, we can actually. This is really cool here. It's really easy to use an array instead of a linked list type structure or using nodes. We're going to use We're going to use an array. It's fairly straightforward. It's kind of magic. What we're going to do is we're simply going to read in that left to right order from top to bottom, this level order as I called it, and just simply insert it into an array in the level order. So boom, 8 goes into index 0. Then we follow it with 18 and 29. Then we follow it with 20, 28, 39, 66. And then the next level just goes into this spot over here. Right? So so that's all that it takes, basically, right? If we read from the heap from left to right, so read along with me but you can read along to the array, and I'll read from top here. 8, 18, 29, 20, 28, 39, 66, 37, 26, 76, 32, 74, 89. And that's it. And so that's how we store things. So we're going to store it in a heap. And this kind of makes sense now why there can't be any gaps, because if there was a gap, why there can't be why it's a complete tree. If it wasn't a complete tree, that means there would be gaps, and we wouldn't want a gap, So if we didn't have a node here, we'd have a gap here at index 6, which would make things a bit difficult when we want to do some of our operations. Since this is an array, you don't have references to your children and you don't have references to your parents. So how do you figure that out? Well, it's a very, very easy formula, which apparently is not rendering nicely here, because converting these things don't necessarily work well with LaTeX. So not LaTeX. With LibreOffice, right? All right. So if you're a node at position P, if you're a parent at position P, then you can find your children at 2p plus, you can find your children at 2p plus 1 for your left child, and your right child is at 2p plus 2, where p is your index. So for 8, right, its children are at index 0 plus 1 and 0 plus 2. 18's children are at indices 2 times 1, right? So my index is 1. So, right, my index is 1. My left child's at 2 times 1. So that gives me 2 plus 1. So total 3. So we see my child's 20. My left child's 20. And my right child is, again, 2p plus 2. So we'll see that my right child is over here at index 4, which is twice my index plus 2. Right? For 29, again, it's 2 times 2, right? That's my index, is 2 times 2 gives me 4, plus 1 gives me 5. So my left child's at index 5. And my right child is at 2p plus 2. So it's at index 6, right? 4 plus 6. Sorry, 4 plus 2 is equal to 6. So this formula works out pretty well. Now the other way around, if I'm a child, and I want to figure out my parent, if you're a child at position C, you can find your parent by taking your index, subtracting 1, and divided by 2. So right, so 74's parent is 39, and we know that because 11 minus 1 is 10, divided by 2 is 5. So my parent is 5. It's fairly straightforward. So it's a fairly straightforward formula. It is one that you will see on the timed lab. So be sure to note that it's in the slides. Okay. So inserting into a heap implemented as an array list. So how do we insert this? Well, how do we do this overall? I think that's worth splitting up into another video.